to work with slabs. And I started with one-way slab. One-way slab is a piece of cake. We just need to figure out what is the minimum thickness for the slab, and we can figure out the own weight, superimposed dead load, and live load. And we can take one strip with unit width in the short direction. Make sure one strip with unit width in the short direction, and then I can draw bending moment if it's simply supported, or two span or more than two span. So I can figure out the bending moment based on the on weight, superimposed dead load, and the live load. Don't forget to make combination in ultimate. So dead load time 1.2, live load time 1.6. Once I get the moment, I can design to figure out how much steel reinforcement. I need to check this steel reinforcement to be more than or equal the minimum. And we covered this example last time. Do you have any question? Looks good. Looks good. Today, I will start to talk about another type of slab. It's not simple, but it's interesting. Because actually in the real life, if you are engineer, if you are designer, I will not use my hand calculation to design slab. I will use a software. And I promise you by the end of this semester, the last week, we have project. And this project, I will solve it with you. Don't worry, because I need you to learn this project. And I believe this project is most important part in this course. This project, I'm gonna use software. I'm gonna use something called floor or Riza floor. This software is another product for Riza, will help you to design slab, beams, columns. In a few minutes to be realistic. Few minutes, I'm gonna design slabs, beams, and columns. And I'm gonna show you how to use Riza Foundation. It's another product for this software. This software can help you to design any foundation, actually for footing. So what you learned in this course by hand calculation, we will cover it in 1 week using a software by providing you a small scale for your capstone project. So I'm gonna give you a building. This building has floor with a slab and the beam, with column, with foundation, and we need to design the whole building as concrete structure, but using software, not hand calculation. Okay, so it will be very interesting, very, very interesting, and most important, very important also. Okay, guys, the second type of slab, which called two-way slab. Two-way slab means, from the meaning or from the name, two-way, your slab is supported at 4 locations from all sides. That means your load can walk, can be moved, can be supported in this direction and this direction. So we have two-way or two directions. So two-way slabs are slabs that are supported on 4 sides. In two-way slabs, the load will be carried in both directions. That means the main steel reinforcement in both directions. Guys, do you remember I told you for one-way slab, we have what? We have main direction, and we have secondary direction. The main direction, we have main steel reinforcement, area steel main. In the other direction, we have minimum reinforcement, just minimum. So we have only one direction. But for two-way slab, we have two direction. That means the main steel reinforcement will be provided in the two directions. The slabs are considered as spanning two-way. This condition is very important. When I consider the slab to be two-way, if longer divide shorter is less than 2. So longer divide shorter less than 2. Sometimes your two-way slab, sometimes with beams. Can you watch this picture, please? Between this column and this column, we have a beam. We have a beam. We have a beam. We have a beam from 4 sides. And these beams are supporting this slab. So we have two-way slab with beams. Sometimes we don't have beams. The slab is supported directly on column. So can you watch this square or this rectangle shape? We have here a column. We have here a column, column, column. So your slab is supported at these corners by columns directly. So we have two-way slab without beams. Any question so far? Any question so far? We need to understand, we need to figure out, we need to understand what is the meaning of this concept. Very important. Okay, I'm gonna focus a little bit on this slab. By the way, this slab, which is two-way without beams, can be called flat slab. Sometimes we can call it flat. Flat means we don't have anything dropping down from the slab. It's flat. Just slab rested on columns. For two-way slab without beams, the normal or the regular shape is this one. Just a slab rested on columns, like this. Your column may be a circular column, square, rectangle, whatever the shape of the column, I don't care. But the slab itself rests directly on the column. Sometimes your, do you know, let me explain it here. If you are sitting at home right now, can you bring a piece of paper like this? Can you try to fold down your pencil with sharp point on the paper? What do you expect? If this pencil fall down on the paper, so what do you expect? What will happen for the paper? What do you expect? Any answer? Make a hole. This hole or this phenomena can be called punch. The pencil will punch the paper. Okay, can we flip this shape? We have a slab with a little thickness. It's okay, 4 inch or 5 inch. It's still very thin. 4 or 5 inches, nothing. And we have a column. And this column underneath the slab. If this column is small, for any reason, we will cover it next week. And this slab, it's not thick enough. So what do you expect at this connection? We expect bunching. That's right. We expect bunching. So what is the solution for this phenomena? We have different solutions. The first one, increase this thickness rather than 5" to be 10". But it's costly. You will spend too much money because you increased the thickness for the whole slab only, for this region only. Doesn't make sense. Or you can increase the column, the cross section of the column be bigger. Or we have these solutions. This one called drop panel. At this region around the column, I'm gonna increase the thickness of the slab to be 10". But the remaining slab will be 5". Guys, at the top of the slab, it's flat, but this difference in thickness will be from the bottom. Because you are walking here, you are sitting on the slab, on the surface. So I don't care about the bottom. So what happened? I increased the thickness only around this region. Can you watch this video? It's a real video. I'm sorry, this photo. It's on site photo. So I increased the thickness of the slab at this region only to make sure to avoid the bunch coming from this column to bunch this slab. This is called drop panel. Drop panel. We have another solution which called column head. So this one avoided to increase the thickness for the whole slab. We just increase the thickness of the slab around the column. For this one, for head column, avoided to increase the cross section of the column. We just increased the cross section at the top of the column. So we did something called column head. Sometimes we can combine this solution and this solution for one solution like this. Can you watch this photo? It's a drop panel with column head. So I increased the thickness of the slab at this location only, and I did something called column head by at the end of the column at the top. So any question? Guys, do you have any question? So in the real life, if you are watching something like this, it's a flat slab or two-way slab without beams, but we have drop panel. If you are watching something like this, we have column head or column head with drop panel. But most of these slabs will be like this, just a slab rested on columns. Okay. We need to figure out the thickness of the slab. What is the thickness? So we have two situations. First one, if you don't have beams, no beams. So based on the type of steel, if your steel 40,000 F yield, 60,000, high strength steel 75,000, so I can select which condition. If you have drop panel or if you don't have drop panel. if you have edge beams, if you don't have without or with edge beams. So you need to think what condition do you have? I'm gonna start from the beginning. Do you have interior beams or not? What type of steel you are using? Are you talking about exterior panel at the edge or interior panel? Do you have drop panels or not? Based on these conditions, I can decide which expression I'm gonna use. By the way, Ln is the clear span in the long direction of the slab measured face to face of column. What you mean by face to face? What do you mean? Let me go to the homework number 6, I think. Here you go. Guys, can you watch this homework, for example? The distance between this center line and this center line, how much? 22 feet. This one called L. But if you are talking about Ln, which means clear span, which is the distance from this face of the column to this face of the column, this one can be called Ln. It will be smaller than 22 a little bit, but to make sure you can understand what is the meaning of Ln. Ln is the clear span. Clear span means face to face. Face of this column to face of this column. But the total span means center to center. Okay? Okay. If you have interior beams, it will be more complicated, but I'm gonna suggest to use 5" without all of these details. Forget all of these details. Just use 5" as a minimum thickness. If you have beams, interior beams. Any questions so far? Okay. Guys, for one-way slab, we assumed strip with unit width. But for two-way slabs, we need to divide your slab to many strips. The first one called column strip. The second one called middle strip. By the way, middle strip are supported by column strip. So guys, what do you think? Column strip, what is the meaning of column strip? What is the meaning of column strip? From the name, column strip. What does it mean? If we are talking about X direction, this direction, X. What is the meaning of column strip? Yeah. I'm talking about, Oliver, I'm talking about if you have flat slab with interior beam. Just to make sure everything is good. For your homework, we have two problems. Problem number 2, can you watch? Do you have any interior beams? No. Second problem, do you have any interior beam? Yes. By the way, interior beams or beams in concrete can be defined by these two lines. We have a column here. We have another column here. In between, we have two lines. Can you watch them? These two lines represent that we have beams in between. If you go to this figure, between this column and this column, do you have multi-line? Do you have this thing, double line? No. So we don't have beams. This one with beam, this one without interior beam. Guys, all of these stuff are very important. Doesn't make any sense for any student after graduation. He cannot understand, he cannot figure out this is slab with or without beams. These symbols are very important. You should learn this stuff during your AutoCAD course. If you are talking about beams for plan of floor, beams represented like this. Columns represented like this square or this rectangle, whatever the shape of the column. So if you have something like this, and sometimes we are providing center line. This shape in the real life represent, I'm talking about floor plan. This shape represent column. These two lines represent beam between this column and this column. Or you have a column and you have another column and you have center line. That's fine. Center line just for construction. That's fine. We don't have anything in between. That means we have a slab without beam. If you are looking to your final floor plan, this one is flat slab, slab without beam. This one with beam. Any question for this point? Any question for this point? Guys, it's important. It's important. Okay. So, my question is, what is the meaning of column strip? Column strip means I will come to X direction. I'm talking about this direction, X. I will come to this column and this column and this column and this column, and I'm gonna assume strip from this side and this side. And this strip is supported by what? This strip is supported by what? This strip looks like this. Supported here by this column. And here by this column. And here by this column. And here by this column. Do you agree? Do you agree? Do you have any question for this point? Guys, what I'm talking about, just to understand. Just to understand. Because this point is confused a little bit. It's confused. So make sure you can put your hand what's going on. Okay, for this column and this column and this column and this column, we have another column strip. And the same meaning. This column strip, if you are talking about structure analysis, will be looks like beam supported at these columns like this. And we have column strip here and the column strip here. Anybody has any comment, any question until this moment? these green strips called column strip. I'm talking about, by the way, I'm talking about X direction. So this length can be called L1. And this length from center line to center line can be called L2. So L1 in X, L2 perpendicular to your direction. Anybody should ask me a question here. What is the question expected at this point? What is the question? What is the question regarding column strip? What do you think? You should ask me a good question. This question is, what is the question? What do you think? The load. Okay, it's a good question. How big? Thank you, Burak. Width. That's a good question. In one-way slab, we have a strip with unit width. But here, no, it's not unit. What is the width here? Why you stop? Why I'm stopping here? Why not here? Not here. So what is the width? What is the width of this strip? You are talking about column strip. That's right. What is the width of this strip? That's right. Okay. From this center line to this edge, we have a value, which is 0.25 L1 or 0.25 L2. The smallest value. L1, this distance from this center line to this center line. L2, this distance from this center line to this center line. Please go ahead and get the quarter of these lenses. So I have a value here and I have another value here. Please use the smallest one. The smallest value will be this width from this side. We have the same on the other side, so I can figure out the total width of this strip. So in this example, L1 equal 22 feet, L2 equal 22. You are lucky. Both of them are equal. So if you multiply 0.25 times 22, your final will be 5.5 feet from this side, 5.5 feet from the other side. So the total width will be 11 feet. Any question? So I have 11 here also. So 5.5 from this side and the 5.5 from the other side. From this center line, I have 5.5. From this center line, I have 5.5. Any questions so far, guys? So column strip is a design strip with a width on each side of a column center line equal to the leader of 0.25 L2 or 0.25 L1. Column strip shall include beams if you have beams. If you have beams. Any questions so far? Looks good. Looks good. One of you will ask me, what about the second strip? We have another strip called middle strip. So how can I figure out the middle strip? No, you don't need to figure them out because you are done. The strip remaining between column strip and column strip can be called middle strip. So this strip, the remaining distance, you don't need to figure them out because they will bob up alone. These red strips can be called middle strip. My question to you guys, can you tell me what is the width? So what is the width here? I can't figure it out. I have a distance here from center line to this edge 5.5, and I have another 5.5 here, so the remaining distance will be the width. Actually, the total distance is 22. So 22 minus 5.5 minus 5.5, so it will be 11 feet. This width will be 11 feet. This width will be 11 feet. So I divided my beam, I divided my slab in X direction to column strip and field strip. Anybody has any question? Thank you, Oliver. Thank you, Burak. Okay, I have question. Please pay attention. Please pay attention. Guys, I told you the column strip, and that makes sense. The column strip is supported by this column, and this column, and this column, and this column. What about the middle strip? If you are talking about this strip will be supported by what? Do you have anything at the middle? You have any support inside this strip? Wow. So we need to figure it out. No. Rebars, not support. I'm talking about support means we have column, we have another beam, we have something to support. Reinforcement are not support. Reinforcement to support moment. But I'm talking about member. What is the support for these members? Longitudinal column strip. It's a good answer, Oliver. But what do you mean by longitudinal column strip? It's a good answer. But what is the relationship between this column strip? You mean this column strip? Thank you, Mary. Yes. Guys, what you did in X direction must be done in Y direction. So, at this column, we have here column strip. Can you watch this column strip? And we have here another column strip. And we have here another column strip. And we have here another column strip. So, if you are looking to this middle strip will be supported here by this column strip, and this column strip, and this column strip, and this column strip. Which column strip? In Y direction. You got it? You got it? So guys, I need to divide. I need to sketch my plan to something called column strip and the middle strip in both direction, in X direction and Y direction. And make sure you can understand this point. It's very important. You cannot find many to understand this concept. This strip is middle strip. Middle strip means no contact with the column. This middle strip is supported here and supported here and supported here with what? The column strip in Y direction. The column strip in Y direction. The column strip in Y direction. Also, it's very important to figure this out. If you are talking about middle strip in Y direction, this middle strip will be supported here by column strip, this column strip, and this column strip, and this column strip. Support here, support here, support here. This slide is very important. If you can understand it, so you can understand the sequence of loading or the mechanism of loading on two-way slab without beams. I'm talking about we don't have beams. Without beams. So how can the slab carry each other? How this slab can carry each other. So we divided it to strips, and one of these strips carrying the other strip. Column strip supporting middle strip. But which column strip? The column strip in this direction supporting the middle strip in the opposite direction. Little square. Which square? This one? You are talking about this one? It's not a little square. This one is a part of this strip. Guys, remember, your strip, it's not a line. I'm trying to assume it a line to make looks like beam. But it's not a line. Your strip is a width. The whole width. So the whole width, this width, the whole width is supported here by this strip and this strip and this strip. But if you are talking about structure analysis, I'm gonna assume this strip looks like a line and the supporting strip looks like one support. But in the real life, it's not one line, it's an area supported by another area. Okay, Oliver? Okay, that makes sense. Okay. So guys, this point is very important. You need to understand it. Okay? Actually, for this week, I'm gonna focus on understanding the concept, the mechanism of these slabs. Because on Friday, I'm gonna solve this homework with you. It's not a big deal for me. As I told you, we recommend to solve slabs by software because it's not easy to do it with hand calculation. But the most important part to understand what's going on. Okay? Final step, we need to figure out what is the moment. By the end of this sketch, all of this division, all of this stuff, I need to figure out. We have a column strip, something like this, supported by column. So what is the moment? I need to draw a moment. And if you have middle strip supported by column strip, we need to figure out what is the final moment. Because once you draw bending moment, your design is done. Because M ultimate divide phi BD square, I can figure out this number, so I can figure out the row, so I can figure out the area still. That's it. That's it. So how can I figure out the moment? I will go through it quickly. First step, we need to figure out this value, total moment, M naught, which equal Q ultimate. I'm talking about a method called direct design method. It's very simple, the most simple method in ACI. So Q ultimate, which is 1.2 dead load plus 1.6 live load, which call it W ultimate. In ACI, they calling it Q ultimate. Anyway, so not a big deal. L2, if you are talking about this direction, which is Y, L2 is the perpendicular direction from center line to center line of columns. Ln is the clear distance between this face of column and this face of column, Ln. So I'm talking about strip, for example, in Y direction. If you decide to talk about X direction, okay. If you are talking about X direction, Ln will be from face to face. This is Ln. L2 will be from this center line to this center line. So L2 all the time perpendicular to your strip. Ln in the same direction of your strip, but from face to face. Ln in the direction you are considered. L2 perpendicular or in the transverse direction. I calculated Mn, which is a value. One value. Once you calculate your Mn, your M naught, I'm gonna divide this M naught between positive and negative values. 0.65 to the negative, 0.35 to the positive moment. The positive moment will be divided between column strip and the middle strip. The column strip will get part based on this table for interior panel and based on this table for exterior panels. If you have beams, the beams will take 80.85 from the column strip moment. Once you divide your moment between column strip, the remaining moment will be for middle strip. This part, how to divide your calculated moment between column strip and middle strip, I'm gonna go through it in more details on Friday by helping you to solve this problem and this problem in the homework.